This is the first video for Chapter 6 of Pre-Calc 11, where we're going to go over the basics of what rational expressions are, and then talk about some specific restrictions on what numbers they can have. So if you are just getting into Chapter 6, this is the perfect place to start. So Chapter 6 is all about something called rational expressions, which isn't really as complicated of a concept as it sounds. A rational expression, really at the end of the day, is just a fraction. And basically it's a fraction with a polynomial, but typically the polynomial is going to be in the denominator of the fraction. So that could be something as simple as an x, or maybe as complicated as a quadratic, or even something worse than that. But since this is Pre-Calc 11, we're just going to stop at quadratics. You might have variables just in the numerator, just in the denominator, or both. So let's look at some examples. One over x is pretty much as simple as it gets, but it might be something a little more advanced, like 2x over x minus 4, or even something like 2x squared plus 3x plus 1 over x squared minus 4x plus 8. So just like when we were dealing with radicals in chapter 5, there are some numbers that don't work with our rational expressions, and that's what I'm really going to focus on in this video. So in this chapter, we're going to do things like add and subtract, multiply and divide, solve equations, the same sort of stuff that we do with a lot of our concepts in this course. But for this specific video, I'm really just going to be focusing in on when do these things work and when don't they work, because that's something that we're going to have to worry about pretty much with every single thing we do in this chapter. So with radicals, those were our restrictions, right? We had to make sure that our radicand was positive. You couldn't have negatives inside of a root. But that's not really a thing with fractions, right? You can have negatives in the denominator of a fraction. It's not a big deal. You can have positives. There's really actually just a specific value that's a problem when it comes to fractions. So the key thing to remember is that a fraction represents division. And so if your fractions are going to represent division, if you think about division, remember there is a specific number that doesn't work, and that number is 0. So we can't divide by 0, ever. And so that number is really going to be the key to all of our restrictions when it comes to these rational equations, expressions, and whatnot. So any value for our variable, or variables if we have more than one, that would make the denominator be 0 is not okay. And that's what we're going to have to look for every time we do one of these questions. And so we have a specific name for those values. We call them non-permissible values. Right? They're not permitted, they're not allowed. That's a mouthful. I'm not going to write or say non-permissible values very often. So what we're typically going to do instead is just call them NPVs, because that's much simpler and more straightforward. And so every time you do something in this chapter, every time you add or subtract, multiply, divide, simplify, whatever, you're going to have to find NPVs unless they're already given to you. And so that's what we're going to focus on in this video. So let's start with some basics. So we're going to determine the non-permissible values for a whole bunch of different rational expressions. So starting about as simple as we can with just something like 4 over x. So it's only the denominator that matters, right? The numerator can absolutely be 0. You can do 0 divided by whatever you want. That's okay. You just can't divide by 0. In this case, since our denominator is just x, we just would say that x cannot be 0. So this is what an NPV looks like. You're saying what x cannot be. There's no greater than or less than here. It's just a cannot be this number. But it's not typically just going to be an x or something along those lines in the denominator. There's usually going to be stuff going on. So something like this, 2a times a plus 3. So as a general rule of thumb, to find NPVs, it's a fairly straightforward process. And it's a lot like what we did with our restrictions with our radicals. What we're going to do is we're going to set the denominator equal to 0, or rather not equal to 0. And then we're just going to solve. So we're going to be doing a lot of equation solving in this chapter. So in this case, we'd have a plus 3. That's our denominator, and we would just set that as cannot be 0. And then that cannot equal works the same way as an equal when it comes to solving. So to solve this, we're just going to subtract 3 on both sides, and we end up with a cannot be negative 3, right? Because negative 3 plus 3 would get us 0. And so that's what you're going to do every single time. All right. Let's just keep going. So 2y plus 9 over 3y minus 12. Again, we're just going to completely ignore that numerator, that 2y plus 9. I do not care about it in the slightest. So we're just going to take the 3y minus 12. We're going to say that can't be 0. And then we just solve, right? Opposite operations. Move things to the other side, isolate y, same as usual. So we're going to add 12 on both sides, which is going to get me 3y cannot be 12, divide by 3, and we end up with y cannot be 4. Right, and again, you can kind of mentally check that. 3 times 4 would be 12, and 12 minus 12 would be 0, which is no good. But a lot of the times we're not going to have linear expressions, linear polynomials in our denominator. A lot of times we are going to have quadratic things, like this. And so the same principles apply. We're still going to take that denominator, x squared plus 7x plus 10, and we're still going to say that can't be 0. But now we're not necessarily going to be isolating our variable. We're going to be solving maybe a slightly different way. So this is a quadratic equation, or quadratic not equation. We spent an entire chapter on this back in chapter 4. So remember, you've got 4 ways of solving this: graphing, factoring, completing the square, or quadratic formula. You're not typically going to graph these, for sure. You're probably not going to complete the square because we don't really want them to be in vertex form. So most of the time you are going to be factoring, because we're going to be doing a lot of factoring in this chapter. So I'm going to say right now, if your factoring is a little rusty, you need to go back and check out some of the factoring videos from earlier in this course. Find some factoring stuff online, come see me to get some help. But factoring is by far the most important skill to be successful in this chapter. So make sure you know how to factor. There will be times maybe where we use the quadratic formula, but those are going to be a lot more rare. So if we factor this, we want 2 things that multiply to 10 and add to 7. That's going to be 5 and 2. So we have x plus 5 and x plus 2 can't be 0. And so those would give us x cannot be negative 5 or negative 2. Remember, to get those 2 things, what you basically do is you take each of those factors and you set them not equal to 0, and then you would just isolate. So you'd subtract 5 on both sides, and that would get you x cannot be negative 5. And you would do the same thing with x plus 2 to get x cannot be negative 2. All right, so x squared plus 6x plus 5 over x squared minus 10x minus 24. So go ahead, pause the video here, try to do this one yourself just to get a little bit of practice, and then come back, see how you did with your factoring, and see if you solved it properly. So we've got x squared minus 10x minus 24 can't be 0, right? So we want to multiply to 24, or negative 24, and add to negative 10. So your kind of most common options are going to be either 6 and 4 or 12 and 2. And in this case, it is going to be negative 12 and positive 2. So we got x minus 12 times x plus 2, which gets us that x cannot be positive 12 or negative 2. And so really, it's just factoring and solving every single time, every single question. So you're going to be doing this so often, which means your factoring will get lots of practice, but it also means that if you're not up to date with it, you're going to really struggle. Okay, so on this one, just as a quick refresher for your factoring, if you've got that number out front, that 2, there are 2 things that we can do. First, we always want to check to see if we can take out our a value as a common factor, because that is going to make our factoring much easier. And in this case, we can. So we're going to take out that 2, which is going to leave behind x squared plus 6x plus 5. Cannot be 0. And so the 2 is not really going to affect things at this point. If we factor what's in the brackets, that's going to get us x plus 5 and x plus 1. And so our solutions, or rather our NPVs, are that x cannot be negative 5 or negative 1. This 2 is just a 2, right? It's never going to make anything equal to 0 because it's just a 2. But what if we can't take out the a value as a common factor? Right, so if we have something like 3x squared plus 8x plus 5. So immediately you can tell, okay, 3 is not coming out from 8 or 5. This isn't going to work that way. So one quick refresher example. I'm not going to do this every single time. We're going to be doing a lot of factoring in this unit, and I'm just going to go through them quickly most of the time. But one quick refresher on how to do these. So when you can't take out the a value, what you're going to do is you're going to multiply your a and your c. So 3 times 5, which is 15. And you want to find 2 things that multiply to 15 and still add to 8. So we're multiplying to 15, adding to 8. There's not really many options there. It is just actually 3 and 5 again. Typically, it's not going to be the same numbers. So what you're going to do is you're going to take that b value, that 8, and you're going to break it up into those 2 numbers that you found, which in this case are 3 and 5. So we're going to have 3x squared plus 3x plus 5x and then plus 5. You're going to make groups of your first 2 terms and your last 2 terms. You're going to take common factors out of those groups. So from our first group, 3x squared and 3x, I can take out, well, 3x, which is going to leave behind x plus 1. For my second group, I can take out 5, which is also going to leave behind x plus 1. And then remember, those 2 brackets do need to match. If they don't match, you've done something wrong and this isn't going to work. So we're going to take out that repeated binomial factor of x plus 1 and then combine what's left to get 3x plus 5. And then to get our solutions, or our NPVs, we just do the usual thing. So we'd say x cannot be negative 1 and x cannot be negative 5 over 3. So you'd have to take that 3x plus 5 and solve it. And there we go. So that's what happens when your a value doesn't come out. So again, if you're a little lost on that, do make sure you go back and practice and rewatch the videos. All right, so going through a few more specific examples, some cases you might run into. So this is something you might get presented to you in this format, or you might also have gotten it given to you as just x squared plus 4x. Either way, same thing. So when you have a variable that's just on its own like that, that is something that I do find that students tend to get a little mixed up on. So most of you will be totally okay telling me that x cannot be negative 4. But when the variable is by itself like that, it's just going to give you a 0. Right, because if you put 0 in for that x, 0 times anything is still going to be 0, and we don't want that. So if your variable doesn't have anything being added or subtracted to it, The NPV is just 0. All right. What about something like this? So x squared minus 9. You may or may not remember that this is a specific kind of polynomial, and it's got a specific way of factoring it. So remember, this is a difference of squares, and differences of squares always factor the same way, where it's the square root of the first thing, so in this case x, plus the square root of the second thing, so in this case 3, and then the same thing but with a subtraction. And so our NPVs are just going to be plus or minus 3. Okay, continuing on. What if that second thing's not a perfect square, though? We could kind of try to go through it the same way, but a different way of solving this is actually just to isolate our variable. So we can add 6 on both sides here. And this does only work because we don't have the x term, we just have the x squared and the 6. So this gets me that x squared cannot be 6, and then to get rid of that square, we're going to square root both sides, and so we'd land at x cannot be plus or minus. So remember, when you bring in the square root, you got to do the plus or minus root 6. That's not something that's going to come up super often, so don't worry about that one too much, but just know that it's a possibility. Okay. Similar idea. This is not a difference of squares because it's being added instead of subtracted. So we can't factor it the same way we did example 9 up here. So let's try isolating it and see what happens. So if I subtract 1 on both sides, I'm going to get x squared cannot be negative 1. And if I square root that, we're going to hit a bit of a problem, right? We cannot square root a negative. So what this is telling us is that this equation has no solutions, which for our overall thing means we actually have no NPVs. There's nothing that's ever going to make this denominator be 0, which is okay. All right. A couple more just very specific things. There are going to be cases sometimes where you have multiple variables in your denominator. So you might have an x and a y. It doesn't come up super often, but it is something just worth to be aware of. So if everything's just being multiplied together, so if you have, and let's throw a z in there too, just to add things. So if you just got variables being multiplied together, it doesn't matter what they are, it doesn't matter what coefficients you have, it doesn't matter what exponents you have. If you're multiplying things and getting 0, that means that one of those things has to be 0. So no matter what, when you deal with cases like this, your NPVs are all just going to be 0. Right? Because if you put 0 in for any of those things, 0 times a bunch of stuff is just going to get you 0. So if there's no adding, no subtracting, don't think about it too much, just make your NPV 0. But what if there is addition in there? So what if you have something like, say, x plus y instead of x times y? Well, in these cases, we would still go with x plus y can't be 0, and we'd still try to isolate one of those variables. It doesn't really matter which one. I'm going to isolate y, so I'm going to move x to the other side. And so we'd get that y cannot be negative x. And so instead of giving us a specific NPV, this is actually giving us infinite NPVs, infinite pairs of x's and y values. So you can kind of think of it as there's like a line that doesn't work rather than being a line that does work, which is how most things are done. So any pair of x and y values that fits that little equation is not going to be okay. For example, if x was 1, y could not be negative 1. If x was negative 3, y could not be positive 3, or if x was 0, y could not be 0. Right? So any of those would not work out for us. This is something we're really not going to run into very often, so don't think about it too much. Just know that that is a case that can happen. All right, so last little bit of this, just something that's going to kind of lead into the next part of this unit. rational expressions really are just fractions. And so, like fractions, we can sometimes manipulate them to change them and make them look like what we want them to look like. So the next video is really going to be focused almost entirely just on simplifying, in the same sort of way that you'd simplify a fraction. But there's also something else we can do to make our fractions maybe bigger if you're trying to make them match, and that's multiplying them to maybe change the denominator or do whatever. So thinking something like 2 over 3, right, we can multiply the top and the bottom by 2 to get 4 over 6. And so these are what we call equivalent expressions. And so we can do the same thing with our rational expressions. And we don't just have to multiply by numbers. So if you have something like, say, 2x over x plus 4, you can multiply the top and the bottom of this maybe by x, or even by, say, x plus 1 or something along those lines. And so that would get you 2x squared over x squared plus 4x. And these are also equivalent with one small exception. The only difference is that the one on the right has an extra NPV. And so we've really got to watch for those NPVs when we're doing things. And so there you are. Hopefully now you've got a good sense of how non-permissible values work, because you're going to need to do them a lot. So in the next video, like I mentioned, we're going to really focus in on simplifying these things, much like how we simplify fractions. And then from there, we're going to learn how to add and subtract and multiply and divide and do a whole bunch of other things. So once you're ready, move on to the next video and see how it goes.